Hello, my name is Beth Dixon, and I am the Math Lab Coordinator here at Walter State Community College, and I work in MBSS 222 in the Math and Behavioral Social Science building. It is my job to help students with their math courses here at Walter State, and I do these podcasts to supplement the classroom lectures. They are not meant to replace the lectures and are just to show how to do certain examples in a little bit more detail maybe than what the teacher had time for. In this case, though, I do want to preface this particular podcast with a refresher on what a ratio is. A ratio is a statement of how two numbers compare. And in this case, we're comparing two numbers, and we can compare the two numbers in different ways, but we chose in mathematics to compare these two ratios as fractions or as a division, because fractions are just a division problem. And we're comparing them, the size of one number to the size of a second number. And we can write these fractions, or these ratios, three ways. And I think that's one of the confusing things to students is that we write them three ways. But we write them based on their applications. Some applications write them one way, some applications write them a second way, some applications use the third way. But they really mean the same thing. And as we write this, let's look at the three ways that we can write a ratio. And as we look at this, the first way we write the ratio is with the word 2. The second way is with colons. And the third way is as a fraction. Those are the three ways that we use to write a ratio. If in a daycare there is a standard that there has to be one teacher to 6 children, then we would say 6:1 ratio, or 6:1, or 6/1. Except I read the other two wrong, because we read all of them as 6:1, a 6:1 ratio, a 6:1 ratio. Even though they're written in different ways, we read them the same way as 6:1. So when we're writing it out, we use the word 2. If we're talking about a ratio and we want to use the ratio in shorthand or mathematics, we'll often go 6:1, 6:1. And if we're doing our math problems and we're reducing and doing math with it, we often need to write them in fraction form. So that's why we have three different ways to write it. So now let's look at some specific examples and some specific directions that we'll see as well. I see that we're seeing through to my second page. I'm going to slide my second page out from under that so you don't get that bleed through. Okay, write each ratio as a fraction in simplest form, 35 hours to 14 hours. Okay, so that's going to be 35 over 14. Now, it said to write as a fraction, so that means I need to use a fraction bar. It said to write it in simplest form, which means we want to reduce this fraction. Ratios, because they are just fractions in disguise, we want to reduce and treat like fractions. What goes into both 35 and 14 is 7. 7 goes into 14 2 times. 7 goes into 35 5 times. So that's a 5:2 ratio. 42 inches to 18 inches. So that gives me 42 over 18. Now, if I put the units there, notice I didn't in the other problem, but if I did put the units actually cancel. We don't need the units if the units are the same. So we have a 42 to 18 ratio. And we want to write it in simplest form, which means we need to reduce. Now, as you're looking at to reduce this, you may see the largest number that goes into both, or you may not. In this case, let's divide both of these by 2 first and get 2 goes into 42 21 times, 2 goes into 18 9 times. You don't always have to see the largest number that'll go into it, just that you see a number that'll go into both of them. Then we can say, well, 21 and 9 are both divisible by 3. 3 will go into 21 7 times. 3 will go into 9 3 times. Then we have it in lowest terms because there is no number that'll go into both 7 and 3. So we have a 7 to 3 ratio. And notice that I'm reading it because we're in ratio form. I'm reading it the same way. Now, in this same section, we do some application problems. And so let's look at these application problems, or an application problem similar to what you would see. There are 48 students signed up to take the test-taking seminar. Of those, 16 students are male and 32 are females. Now, as we write that, we want to be careful that we keep the ratio the way it's intended. Because this one says write the ratio of males to females. So in this case, we want to write the males first. So we have 16 males to 32 females. So that would put the 16 on top and the 32 on the bottom. Whatever comes second goes on the bottom. Whatever comes first goes on the top. Then we want to look to reduce that. What goes into both 16 and 32 is 16. 16 goes into itself one time. 16 goes into 32 two times. And if you're allowed to use your calculator, you can always use your calculator. Clear out the other stuff I had in it. 16 divided by 32, and then hit math and choose your fraction, and it will reduce it for you. So we have a 1 to 2 relationship, 1 male to 2 females. And because we have different units here, I'll keep the units here. Now, the B part says write the ratio of females to males. Notice this one's the inverse of that ratio. So we really could just take the inverse of our answer. But let's start from the beginning because that would be 32 females to 16 males, which would be 32 over 16. 16 goes into itself one time, into 32 twice. So we have a 2 to 1 ratio of females to males. And really, even though it says the same thing, notice that the wording is different. The number doesn't change, but how we look at it does. There's 1 male to every 2 females, or 2 females to every 1 male, but the fraction changes, and it does change. A 1/2 to a 2 is a different number. So the words are important. You have to read the problems. You can't just look at it and write something down. Now, look at the C part. Write the ratio of males to students. Well, the number of males is 16. The number of students is the total number. Let's go back up here and remember that there were 48 students total. So it's 16 students to 48 total. 16 males, students out of the total. So in this case, we want to know 16 males to 48 students. And in this case, we may not see the division, but let's divide both of these by 4. 16 divided by 4 is 4. 48 divided by 4 is 12. 4 goes into itself 1 time. 4 goes into 12 3 times. So you get 1 male for every 3 students. So if I wanted to divide the students up into groups where the number of males and females were equally divided, and it would tell me I'd need 1 male in every group of 3 students so that my males were evenly split up among the groups. But that ratio would be a handy ratio to note it. But 1 male for every 3 students. 1 out of every 3 students is a male. So ratios can tell us and be written from one set of information, can be written in a variety of ways. Okay, let's look at the next problem. And this is about Tom. And Tom's going to go on what I would call a dream vacation. He's going on an 18-day cruise and plans on spending it reading. And we know that Tom can read 1 book in 3 days. And we want to, first of all, write the ratio of books to days. Well, how many books? 1 book to 3 days. Now, I could have made that more complicated. 1 to 3, 1 dot dot 3. And we'll write it all 3 ways there. I could have made that more complicated and made us have to reduce it. In some of your homework, you may have to reduce it, but I was more interested in the B part of this question. That he can read 1 book in 3 days. How many books does he need to take on vacation with him? Well, he's going to be gone for 18 days. And he needs 1 book for every 3 days. Now, we'll get in when we do proportions on another way to solve it, but when it's this simple, we can just look at this. If I have an 18-day cruise, how many groups of 3 days do I have? He'll need 1 book for every 3 days. So in 18 days, how many groups of 3 do I have? So I have 18, and 3 goes into 18 6 times. So I have 6 groups of 3. So he'll need 6 times 1 book for every 3 days. So it'll take 6 times 1, or 6 books. Now, personally, I read much faster than 1 book a day. I can read, even if it's a long book, it'll take me 2 days. I can read 2 books in 3 days. So if I was going on this trip, my ratio would be 2 books to 3 days. Okay, how would that change the problem? Well, I would still have 18 days on my cruise. There would still be 6 groups, but instead of taking those 6 groups and multiplying it by 1 book per day, I would multiply mine, because I read 2 books in 3 days. I would take 6 times 2. I would need to take 12 books. So Tom would need to take 6 books. Beth, because she reads faster, would need to take 12 books. Okay? Now, another application that's probably closer to our heart because it deals with money is what we call a unit price or a unit value or a unit ratio. Um, and this is the kind of problem that we use for um, this type of application. And it says, I go to Walmart and I look for syrup, and I find a 12-ounce bottle for $2.59. And the next week, I go to Sam's Club and find a giant bottle of syrup for $6.89. It has 36 ounces. Which of the bottles is a better buy? So, am I getting a better buy by buying my maple syrup for my son's Eggos at Walmart, or am I saving money by buying the giant bottle at Sam's Club? And Sam's Club looks very tempting because it's the giant bottle and I don't have to go as often, but am I really getting a good deal? Well, the way to figure that out is to find the ratio of dollars to ounces, and then we want to reduce it to per ounce, per 1 ounce. And then what we'll do is say at Walmart, it costs, well, I'm writing all sorts of strange things. It costs $2.59 for 12 ounces. And so if I do that division, that won't reduce. I mean, you can put it in the calculator, 2.59 divided by 12, and if you go math fraction, oh, it does reduce, it gives you an ugly number. Well, who wants to do that? What we want is we want to make it into a decimal. We want to do 259 divided by 12, which gives me 0.2158, and then the threes repeat, so I'm just going to leave it like that. Excuse me, I need to cough. I'm going to step off. Sorry about this. Anyway, and that's dollars for every 1 ounce. So we often write that as 0.21583 per ounce. That's how much my syrup costs at Walmart. Now I'm going to repeat the process for Sam's Club. I just copied my numbers down there. I'm going to take $6.89 divided by 36, and I get 19.138, and then the eights repeat, and that's per ounce. So which is the better buy? Well, Sam's Club is the better buy because it's a couple of cents cheaper than per ounce than the Walmart. So I am better off buying in bulk for my maple syrup. And as an aside, I did make these numbers up. I do not know how much the maple syrup is at Walmart or Sam's Club. And I did not have time to research this before I made it. So these are made up prices. Don't go to Sam's Club and tell them that you want the $6.89 uh, 36-ounce maple syrup. There is no such thing. And don't go to Walmart looking for syrup for $2.59. It could be a lot cheaper or a lot more expensive. Sometimes we do that. It's called taking liberty with math problems. But if the price was different, you would still use the same application. Now, that's a short lesson on some examples in ratio and rates. And again, that last is the unit rates. And if you need some additional help with this topic, be sure to come by and see us in the math lab in room 222 on the Morristown campus. Thank you.